Hey Brandon, so this is the second part of the reviewing the work we did yesterday. We're starting with section 4, problem 11. This problem about Tony and his reading in his novels. The question is, again, we want to read the question first. The question is, what is the number of days it would take Tony to read the entire novel? So we actually looked at this as a unit conversion problem, which often is a way to get at some of these problems that seem a little difficult to deal with. So the number of days per novel, that's the unit we're looking for, days per novel. And so we look for anything in that table that relates time to something about the number of words, the number of pages, the number of novels. And we have number of words that Tony reads per minute is where we can start. So we have words per minute, only we need to flip that because we're looking for days per novel, which the time is on top and the novel is on the bottom. So we need to flip this and have 1 minute for 250 words. Then we can convert minutes to days. And then on the bottom, we want to convert words to novels, and there is a line. The last line is about the number of words in the novel, so we can convert both of those, and that's what we did. So over the time, we'll see a number of problems that are unit conversion. So here we have having to write an inequality. We see the capacity of the landfill is 325, and the question they're asking is, when will the amount of trash be at or over the capacity? So we want to know, when is it going to be equal to or more than or equal to 325? And that looks like D. So let's see if on the left is an expression for how much trash there is, which is the initial amount of trash, 175,000, plus every year there's 7,500 tons more. So there you go. That's D. We put that together very nicely. So we want miles per hour, number 15. Again, unit conversion. We want miles per hour. And what do we have? We actually have miles per year because it says 580,000 miles in 1 year. So that's miles per year. And then we can just convert years to hours. And then we'll have it. And then number 15 is about that if you have a distribution that is skewed to the right, the mean is more than the median. And again, in a distribution, if you see the mean is greater than the median, then that means it is skewed to the right. And that is see a few homes that are valued much more than the rest. That means the distribution is skewed to the right. And then we have, here are the siblings in Lincoln School. And we dealt with counting up from the bottom or down from the top to find the middle students, and there's 600 total. So when we count down from the top to find the 301st student, we find ourselves, the number of siblings is 1. And when we come up from the bottom to find the 300 and 301st student coming from the bottom, it's the same thing. It doesn't matter which way you do it. Okay. Number 21, we have really the problem is a compound inequality because we need it to be within 10 hours of it. It means it can be, there's some number that can be the least it can be, and there's some number it can be the most it can be. So we look for D is the only one that has it in between a lower number and an upper number. So that is D. This one in number 22, we're just solving for R squared. In number 3, we have to think how a change in the value for I means what R has to be different. If the intensity is 16 times greater, then that means R squared has to be 16 times less, so R has to be 4 times less. which means 1/4 of what it was before. Now we have a circle that we've completed the square. Number 24, we've completed the square to put it in the form of an equation of a circle to find out what the radius is. Number 25, we've actually put a value in for A and for B that are simple and they fit the requirements of the problem. You put in one for A, which meant the B must be -1, and we graphed those 2 points, 1, 0, and 0, -1, and found out, in fact, the line has a positive slope. There we got, you did this one very nicely about interpreting something about f of -4 and f of 3/2 and f of 3 to find out that all of them are possible. Now they want to know the equation of the line that passes through B and D, so draw it, and you see that it crosses the y-axis somewhere between 2 and 4, so that could be either B or C. The only difference between B and C is the slope. So is that a slope of negative, that line between A and D, is that a slope of, or B and D, is that a slope of -1 or -1/3? You can actually measure slope, rise over run, and that's -3. Even still, a steep line is a slope greater than 1 or less than -1. And a shallow slope, a slope that is getting pretty close to a horizontal line, is a slope that is just a fraction. All right, and then 29 took a little reasoning of how a parabola could cross twice the line y = 3. It either means it's facing up and has a vertex below 3, or facing down and has a vertex above 3. And so we looked at these coefficients and found that it was B. Number 30, we have to figure out the area of a hexagon. If one of the sides is A, we figured our way to that the area of one of those triangles would be A²/4 times the square root of 3. And when we divide the area of the whole hexagon by 6, we find the area of one of those equilateral triangles. Therefore, we can solve for A, or we can solve for A². And the area of that square is A², and we found out that's 256. Now to the bubble-in questions. So number 33 is a kind of general thing to consider, that if they tell you something that works in the equation, plug it in. 3, 6 lies on the graph of the function. Plug 3 in for x and 6 in for y, and solve for b. Number 34, we're dealing with figuring out how long Laura spent in lab, so we'll let that be L. And Doug spent 40 more hours than Laura, so that's L plus 40. And L plus 40 equals 250. Number 36, the key to number 36 is that each of these angles must be right angles. That's a geometry thing. You don't need to prove it, just need to know it. Therefore, the central angle at O must be 120, which is 1/3 of the circle. So that arc length from L to N must be 1/3 of the whole circumference. This is just a refresher and reminder of what we already did. All right, 37 to 38. We got that crazy formula. And so this is just knowing or practicing how to use the formula. They tell us in this year of 3,000. So we put in 3,000. Oh no, put in 3,000 there, and there. And they say K is, in number 37, K is 4,000. So that's just figuring out what that formula gives you for the number next year. Now, number 38 is a little more complicated. They want to know what this time we're going to solve for K. And what do they tell you? That the number it's going to increase is 360. So this has to be 360. And so we figure out, we know what n the sphere is. We know what point 2 is. So we can figure out what this has to be. Therefore, what this has to be. Therefore, what k has to be. So it's just kind of working your way into the middle of that equation till you can figure out what k is. So that's a kind of quick review of what we did yesterday. And we'll proceed from here. Oh, actually, we're going to switch over to the ACT. And I think we'll be using the a book I'll send you about ACT prep for math. See you later.